Our topic today is inverse operations. The essential question is, what are inverse operations and what are some examples of them? So we'll start off with the definition of inverse operations. These are opposite mathematical operations that undo each other. Knowing what inverse operations are will help you when you solve equations. So as it mentions above, inverse operations are opposite operations that undo each other. So the inverse operation of add is to subtract. The inverse operation of subtract is adding. The inverse operation of multiply is to divide. And the inverse operation of divide is to multiply. So show the inverse operations for each. So when you add 7, the inverse operation of adding 7, or the opposite, is to subtract 7. When you're multiplying, when something's multiplied by 9, the inverse operation of multiplying by 9 is to divide by 9. Now watch how I write divide. Divide by 9, okay? Like a fraction, divide by 9, because fractions are basically division. Okay, the opposite of divide by 10 is to multiply by 10. The opposite of, or the inverse operation of subtracting 12 is to add 12. All right, for this summary, this is what I want you to do. Write this down. It says, what are the inverse operations for each? So what's the opposite of plus 15? Write it right here. What's the opposite of times 6? Write it right here. What's the opposite or inverse operation of dividing by 6? Write it right there. What's the inverse operation of subtracting 25? And write it right there for your summary. Okay, flip it over, please. Use inverse operations to find the value of the variable. Remember that both sides of the equal sign must be equal in order for an equation to be true. So here's what I mean by that. So there's an unknown number right here because it's a variable, and we have to add 10 to it. Once you add 10 to this unknown number, this whole thing, once you put that number in there, has to equal 30. Because this side has to equal 30. So your job when you're solving equations is to figure out what is that unknown number right here. For when you substitute it in, it's got to equal 30. So this one's pretty straightforward. So what number plus 10 is going to equal 30? And many of you are going to say, oh, it's 20. Yeah, the value of x is 20. But obviously problems are going to get a little bit more challenging with more complex equations that we're solving. So I'm going to, in a moment, I'm going to be teaching you a process to solve that. But anyway, I taught you about inverse operations. So the opposite of plus 10 is to subtract 10. And you're going to do that to both sides of the equal sign. Okay? So 10 minus 10 is 0. 30 minus 10 is 20. So that's gone. The equal sign is still there. The value of x equals 20. And here's how you check it. It's called substitution. You take that 20 and you put it right there and see if both sides of the equal sign are equal. So when I put that 20 right there, 20 plus 10 is 30. So this side equals 30, which this side equals 30. So that's why I know that the value of x is 20, and that's my answer. I always circle it after I verify that it's actually correct. All right, number 2. Some number that I don't know, subtract 3 should equal 12. So think of what number would have to equal, what y would have to equal for this side to also equal 12. A number minus 3 should equal 12. So the way I'm showing you is using inverse operations. So you see the subtract 3, the opposite of subtract 3 is to add 3. And you got to do it to both sides of the equal sign. Negative 3 plus 3 is 0. 12 plus 3 is 15. The equal sign is still there. The y is still there. Okay, so y is equal to 15. But you want to substitute it in there to make sure you're right. So does 15 minus 3 equal 12? Put it in there. 15 minus 3. Yeah, that side equals 12. And this side also equals 12, so that's why 15 is the correct answer. Number 3, z plus a half is equal to 8. What is the value of z? So use inverse operations. Look at that number right there. The opposite of plus a half is minus 1/2, and do it to both sides of that equal sign. 1/2, take away 1/2 is 0, so now I'm left with the value of z equals 8 minus a half is 7 1/2. Okay, let's check it. Let's plug it in up there. So 7 1/2 plus a half. That side equals 8. And this side also equals 8, so this equation is true. Therefore, the value of z is 7 1/2. Okay? Something that I should mention real quick is you'll see that the variable of x, it's got no coefficient. It's just by itself. Right here, the y is all by itself. There's no coefficient. The a, it's all by itself. There's no coefficient. There's no coefficient. Right there, it's divided by 3, but they're, well, I'll get to that in a second. And then these ones, there's really kind of no coefficient in front of it. This one does, and this one does. So these ones are going to be handled a little bit differently than these. Okay? All right, so right here, the inverse operation of subtract 1 1/2 is to add 1 1/2. And do it to both sides. Negative 1 1/2 plus 1 1/2 is 0. You'll see a common trend. You're wanting that to get away. Okay? So bye-bye. 10 plus 1 1/2 is 11 1/2. And that's gone, so we're left with a. Bring it down. Okay? Bring down whatever's left. If there is a coefficient, bring it down with it. Okay? Let's double check and make sure it's right. Let's substitute it in. 11 1/2 minus 1 1/2 is 10. So this side, after I've substituted in, equals 10, and this side equals 10. So the value of a is 11 1/2. That's the correct answer. Okay? So you'll notice that you had these 4 problems. You had just the variable without a coefficient, and you added something was added to it or subtracted to it. Okay? So the inverse operation for adding was subtracting. See, you were adding, so we're going to subtract. Right here, we were subtracting. So now inverse operation of subtracting is to add. Okay, we were subtracting right there, so you're going to add and add to both sides, you know. Okay, these ones are the ones that are different. I mean, same process, but it's not, you're going to have to do the inverse operation. So look, we're dividing by 3. The opposite of dividing by 3 is to multiply by 3. And you got to do it to both sides, okay? So what we have right here is 3 times b is 3b. 1 times 3 is 3. And that equals 12, all right? 3 divided by 3 is 1. So 1b can just be written like this with just plain old 1b right there. There's just a b, or you can put a 1 in front of it, doesn't matter. They're saying b equals 12. So now let's substitute it in to make sure we're right. So the original problem. So I'm going to put a 12 right there. 12, ignore all that other junk. 12 divided by 3 is 4. And that's what that side equals. So this side equals 4, and this side equals 4. So that's the correct answer. The value of b is 12. Okay? Now that was a little bit tricky. Let's go ahead and try a very similar problem to that. Okay, the inverse operation of dividing by -4 is to multiply by -4. So please follow that process. Multiply by -4 and multiply the other side by -4. Okay? I see that there's a fraction right here multiplied by that number, so I'm going to make that one a fraction too. So -4 times c is -4c. 1 times -4 is -4. 6 times -4 is -24. Okay, so right here, what's -4 divided by -4? Any number divided by itself is 1. So -4 divided by -4 is 1. We're left with 1c, or you can just write c like that. There's only one c chilling right there. C is equal to -24. The value of c equals -24. But let's substitute it to make sure we didn't mess up. So I'm going to put the -24 there into the original problem. -24 divided by -4. A negative divided by negative is a positive. So -24 divided by -4 is a positive 6. Yep, got it right, because this right here equals 6 after we've substituted in that value. And this side equals 6, so that is the correct answer. The value of c is -24. Okay? So just to reiterate, the opposite of dividing is to multiply. That's why we multiplied. Opposite of dividing is to multiply. Okay, right here. Remember, when you have a variable smushed next to a coefficient like that, that means multiply. This means 5 times a number is equal to 15. Many of you already know what that number is just by looking at it. But I do want you to use inverse operations. 5 times what number is 15? Well, what's the inverse operation of timesing by 5? The inverse operation of timesing by 5 is to divide by 5. And divide the other side by 5. Okay? 5 divided by 5 is 1. 1 times d is just 1d, or just d, same thing. Keep your equal sign. 15 divided by 5 is 3. So we're saying the value of d is 3. Let's plug it in, substitute it, put it right there. Make sure you put the parentheses around it to remind you to multiply. It's not going to be 53. Nope, it's 5 times this value. So 5 times 3 is 15. So this side equals 15 and this side equals 15. Now it's a true equation. So the value of d is equal to 3. It makes that equation true. All right, think about this one. This means negative 2 times e is equal to 14. So negative 2 times some number that we're going to find out when I multiply it is going to equal 14. So what's the opposite of timesing by negative 2? If it helps, you could put a little multiply right there to remember that. Yeah, that means multiply. Okay, the opposite of timesing by negative 2 is to divide by negative 2. And do it to both sides of the equal sign. Negative 2 divided by negative 2 is 1. Because any number divided by itself is 1. Oh, that's a really chunky 1. 1 times e is e, or 1e, same thing, equals 14 divided by negative 2. A positive divided by a negative is going to be a negative answer, so it's going to be negative 7. So let's go ahead and substitute to make sure you're correct. Negative 2 times negative 7, that's positive 14, and that side's positive 14. So after I've substituted it in, this side equals 14, and so does this side. So the value of e is equal to negative 7. All right, so these were one-step equations where you could solve the equation with just using one step. For number 1, we just subtracted 10 from both sides. Bam, we got the answer. Here, the inverse operation of subtracting was adding, so we added 3 to both sides. Boom, we got the answer. Here, the inverse operation of plus was minus, so you subtracted on both sides, and then you got your answer. That's why it's a one-step equation, because we only had to really do one thing, okay? In the future, I'm going to be showing you 2-step equations and multiple-step equations. But really, what really is going to help you is knowing inverse operations, okay? So your task right now for the summary is to pick any 3 of these problems from above, rewrite them, and solve them using inverse operations. And if you gotta do it without peeking. And once you get down to it, double check and see that you got it correct, because all these are the correct answers, okay? So pick any 3 problems from above, rewrite them, and solve them. Bye.